Talking about teams, I think that the real thing that changed in software sort of over the course of my career is that there was a time when you could realistically expect that a single individual, or maybe a couple of individuals, would be solely responsible for producing some genius piece of software. And those times are long gone. I actually went and looked up sort of 3 or 4 landmark video games that were considered sort of groundbreaking at the time they came out. And the 80s were sort of the last time that a single person really was in charge of a software project kind of all by themselves. So software engineering is pretty much a team sport. Any interesting project now is a team project. And that means that to have a successful software career, it's not enough to have good programming skills. You also have to be the kind of person that works effectively with others and that makes your entire team successful. Because one of my favorite team-based quotes from Turing Award winner Fred Brooks is that there are no winners on a losing team and there's no losers on a winning team. It's really an industry where if the team does well, that's good for everybody on the team, and if the team does poorly, it doesn't really matter if there were sort of a couple of people who thought that maybe they were superstars. So as I've said a couple of times, and I've shown even from your previous colleagues who have taken this class, one of the biggest pieces of advice that they said they would give to students in 169 is to have as frequent and sort of as close team communication as you possibly can. And we've been recommending that if it's possible to touch base even every day in a small scrum, just a few minutes to keep everybody on the page. If you've also heard the term stand-up, some people use the term somewhat interchangeably. They're technically not interchangeable, but stand-up is intended to connote that this is not sort of a formal sit-down meeting. It's short enough that conducting the meeting while standing up should not be a burden, so kind of 5 to 15 minutes. And the basic protocol is you go around for everybody in your team and you ask, each person answers 3 questions. What have you done since yesterday? What are you planning on doing next? And what is getting in your way? What is blocking you from the next things you want to do? Sometimes what's blocking you could be that you need to work on a feature and use a mechanism that you're not familiar with, or a library that you're not familiar with. So sometimes it's sort of technical knowledge, things that you have to do. In some cases, other people on the team might say, oh, actually, I have some experience with that library. Let's take 10 minutes and I'll sort of give you a brain dump of do's and don'ts. And sometimes the blockers are things related to the team. Like, I need to add a migration to do X, but I can't do it until somebody else finishes their migration. Or I really wanted to add some foreign keys to establish this new relationship, but I wasn't sure if it was OK to change the database schema. Is there anybody that would, whose work would be really messed up if I committed a change to the database schema? So bringing these things out in the open on a regular basis, sometimes they can be resolved on the spot, and then the blockages go away, and everybody can keep their work going. So when you have these meetings, there's a couple of well-defined roles, some of which you already know. For those of you who don't know the term two-pizza team, it was theoretically, I think it was coined by Jeff Bezos of Amazon. The number of people that 2 pizzas can feed is about the right size for a team. That if it gets larger than that, it's sort of too hard to coordinate, and it's worth trying to split the project down to see if you can have separate projects working in parallel with smaller teams. So one role you already know about because of BDD is the product owner. So when the customer is not actually in the room, the product owner is trying to represent the voice of the customer. We can, I guess, think of them as the customer's advocate. What would the customer say? If we're talking about during the meeting reprioritizing stories, or if we're talking about making a change relative to the stories and diagrams that came out of a customer meeting, what do we think the customer would say about that? And as we know from the BDD stuff, that's also usually the person who is responsible for leading the prioritization of stories for that iteration. Our recommendation for pedagogical purposes is that you rotate this role so that a different person gets to do it on each iteration. With a 6-person team, not everybody will get to do it, but at least if 4 people out of 6 get the opportunity. The other important Scrum role, which is a different person, is the Scrum Master. And if the product owner is the customer's advocate, the Scrum Master is the team's advocate. And this person's job is to essentially make sure that things that could distract or impede the team's progress are getting taken care of, and the team sort of doesn't have to deal with them. So in a corporate environment or a software team environment, sometimes these things have to do with, there's a meeting scheduled that maybe is not essential for my team. Maybe I can go to the meeting and represent the team so that they can keep getting work done. Maybe it's that there's a particular person on the team who is also sort of like acknowledged as an expert on some topic, and people tend to interrupt that person all the time and bug them, and the Scrum Master's job might be to sort of protect that person's time. Sometimes, even in a course like this, if you have an unresponsive customer or if the product owner hasn't been responding, the Scrum Master can push back and say, hey, I'm responsible for the well-being of the team and keeping the team on track. We need you to be more proactive in telling us what the customer wants. If there are team members who aren't contributing or team members who seem like they're distracted, sort of keeping the team on track. If the team has rules about, for example, how you do pairing, the Scrum Master can help make sure that those rules and protocols are being enforced. So in general, anything that would prevent the team from making progress, anything that is and in particular non-technical things that could get in the team's way. In industry, this is more often somebody who has the role for a stretch of time. But again, for the purposes of learning, we would encourage you to try rotating this role during each iteration. We aren't sort of going to police that you do it equally, but we will probably ask you who has been the Scrum Master and the product owner. And I think trying to be in the position where you manage a small team is really valuable. One of the things that both, really everybody in the team, but the Scrum Master oversees is what happens when a conflict comes up during the team. And most of the time, if the product owner is doing their job, the conflict is not about what should we do, but it's often about how should we do it. What is the best technical approach or architecture or implementation for a certain thing? And then how do you resolve conflicts like that? Because I think you have to begin with the assumption that you really are all on the same team. Everybody wants the software to be successful. So everybody is arguing for a particular point of view because they think that's really the best thing for the project. So the first thing to do is actually enumerate the things that the two sides agree on. Where is sort of the first point that they diverge? And you may find that, in fact, the differences between the opposing viewpoints are maybe not as serious as you think. And then, just to make sure, have each side articulate what they think the opposing side's position is. Because often conflicts really come from a lack of understanding or about assumptions that might be incorrect about what the other side believes. So sometimes just sort of getting the information on the table and making sure that each side really thoroughly understands the other's argument. And then assuming that, in fact, there is a difference of opinion, where do you go from there? At Intel, we learned a term called constructive confrontation. And their culture is really kind of built around this. The idea is that anybody who has a strong technical opinion and they think it's best for the project if they were doing it a different way, it's sort of, it's part of their job is to bring that up. It's OK to confront your peers and your boss, but the confrontation is not personal. It's about two people having a technical disagreement. A technique that I recently learned about, which sometimes is used to help resolve this, is what's called the Fist of Five, which sounds like a martial arts movie or something. But basically what it means is kind of like in planning poker, where one of the ways people do planning poker is you can sort of do this like rock, paper, scissors, and everybody votes on how many points they think a story is worth. When you have a disagreement and then somebody proposes a way out, like proposes a path forward, you can have everybody vote with 1 through 5 fingers, where 5 fingers means that's good with me, I'm totally on board, I think that's the right thing to do. And 1 finger means I think you're going to tank the project by doing this. And the idea is that if you have people who are voting sort of 1 or 2 fingers, even if it's a minority of the team or just one person, that should be a reason to try to discuss a little further and come to some consensus. There are times when the right technical approach could benefit from an outsider perspective. Your GSIs can help. I may be able to help on things like this. Sometimes it's really a matter of if one of us has experience having done something similar, maybe we have some piece of information we can contribute. But the important thing is to get to a point where maybe not everybody on the team is 100% on board, but you've decided on a way forward and nobody is saying, all right, over my dead body, is this going to happen? Once you get to that point, and this is another Intelism, it's disagree and commit, right? It's not disagree but commit, because that implies that you're sort of keeping your mouth shut about it. Disagree and commit is you're making clear, I don't agree, I still don't think this is the best way forward, but we've discussed it, this is what the team has decided to do. I will now contribute in any way possible towards making this approach as successful as it can be. Right? So there was a great article about a year ago in Communications of the ACM. Don't think of conflict resolution in a team meeting as who's going to win the argument. It's winning the argument is not the point. Resolving the situation is the point, right? It's kind of like it's the whole team against a technical problem. It's not one faction of the team against another faction. So keep reminding yourselves that you're literally and also figuratively on the same team in trying to get through these disagreements. And Everybody's trying to bring their best ideas to the table. You can argue against an idea, but you don't argue against the person, right? I disagree with your idea because is actually subtly different than I disagree with you because. The idea and the problem that it's trying to solve are the thing that you want to keep front and center, right? So that at the end of the day, you can all still go out and have dinner together or something. As I mentioned before, with a super bright yellow slide, the previous feedback is that having even just a 5-minute daily stand-up, which can even occur on Google Hangouts if you're not all in the same place at the same time, but having just a quick check-in so that if there's any surprises about what people are working on or blocked on, you can get them out of the way pretty quickly. The teams that didn't feel like they communicated enough felt that that really hurt their project. It made it hard to coordinate their work. Certainly the teams that had the strategy of, we're going to have like one meeting a week, kind of like you have one section a week, definitely not enough. And as you get further into the project, I think these things become more and more true. And the teams that didn't sort of designate a person to run each stand-up kind of wish that they had. In fact, you could actually do this if you're meeting multiple times a week, as I really hope you'll get to the point of doing, is you could rotate the position on each one of the weekly meetings, not just on each iteration, and then everybody actually will have a chance to do it. Okay, so learning to work together this is actually one of the most important skills that software companies look for, I think. Best practices around doing team coordination with Git. So as you do release branches, feature branches, what are the kinds of things that can go wrong, and how might you try to avoid some of those things? I think if I had to summarize, do work in small chunks. Commit early and commit often, and when you're working on a branch, in some sense your goal is to get off of that branch as soon as you can, right? Get back to the point where your branch can be rebased, merge back into master, and then get on with your life. There's much better Git cheat sheets out there, but there's a number of things that have to do with undoing things that went wrong. Different forms of Git reset to make the world look the way it was before a botched merge or before a botched rebase. I put them in red because Git reset -- hard is one of the very, very, very few things you can do with Git that actually destroys code. If you're committing early and often, it's very unlikely that any code you write will ever just vanish off the face of the earth. It may take a little work to find it, but you're like, oh gosh, I remember I had done that, and it worked, and I can't remember what I changed. The code is there somewhere if you've been committing frequently. But the one thing that you can do that actually loses information irretrievably is Git reset -- hard. So use with extreme, extreme care. There's many different ways to do the diffs between files. The standard one that you see is if you have the name of a branch or even a commit ID, you can say, relative to where I am right now and how the file looked at that commit or that branch, show me the diffs in specific files. You can also do things like this, which are really useful. Like, show me what the difference between my file is right now and how that file looked on the master branch on this date. So this is of the form, on Tuesday this was working. OK, well, figure out whatever date Tuesday was, and you can actually see the specific differences in whatever the most recent commit was as of that date. You can even say things like, at 2 days ago, if you've been up for 2 days and you can't see straight anymore. You can temporarily show what a file looks like in some other branch without having to switch to that branch. So if you're like, oh, I'm working on a branch, and I'm trying to remember what it was I was fixing, you can actually just temporarily output a copy of the file as it appears in that other branch. And of course, you can ask, with git blame, you can ask, who were the last people to modify each of these lines of this file? Like, damn it, somebody broke this file, and I want to know who to point the finger at. It's kind of a funny named command. But remember, you're all on the same team. Mistakes will be made. You might do something like making the person who appears next to git blame like eat a disgusting candy or something, but keep it collegial, right? Everybody makes mistakes. You're all here to learn. And of course, git log, super useful because every branch has its own commit history. So when you're on a branch, what you want to know is, on this branch, what's happened to this file, as opposed to what's happened to this file on its whole life, no matter which branch it was on. So git log will show you the commits in order, in reverse order for the file just on that branch. Git is, I call it the Swiss Army chainsaw of version control systems. It does everything, and it can be really intimidating. So expect to spend some time Googling, how do I do X with Git? Git can certainly do it, and sometimes the command line options are obscure, but it is there. And ask us if you need help and stuff like that. But Git is a power tool. And as long as you're careful about reset -- hard, commit early and often, and every piece of code you ever write at least will, you won't lose it. Okay, so that's kind of my sort of golden rule. Pitfalls. This one is less of an issue with some IDEs, but here's a scenario. I'm working on some branch. I have some file open in my editor. Now I decide that I need to temporarily switch to another branch to look something up. I temporarily switch to that other branch in my terminal window, but that actually causes Git to modify the file system under you when you switch branches. So now the file that's still sitting in my editor actually has nowhere interesting to be. If I save that file, I'm going to stomp on the version in the branch I just switched to, which is probably not what I want. Now, there are a number of IDEs, like the cloud-based ones, and I think RubyMine, where the editor is sort of Git aware. And if you switch to another branch in the terminal, your editor will do something sensible. Like it'll say, do you want me to switch to the version of this file in the other branch? Or before switching branches, do you want me to save the current version of the file? But just be aware, if you're not using an editor, an IDE that knows about Git branches, this is a possibility. In general, before you pull or merge, make sure that you've committed. Commit early and often. And after you pull or merge, just reload the files into your editor and make sure that the editor is aware that you're on a new branch. Or quit the editor before you do your commits. Say what? Okay. Letting your local copy of the repo get too far out of sync. So git push and git pull, you should be doing them all the time, right? Remember that the GitHub copy of the repo and your copy of the repo are both complete copies of the repo. So anytime changes are being made on one, they should be propagated to the other as soon as you can, because otherwise, when it's time to do merges, they will be painful. I make it a habit that when I sit down to write code, I immediately do a git fetch or git pull before I start to make sure I have the latest version of what's in the origin repo. As soon as I reasonably can, I'll do a push, even if it just means I'm pushing my own branch, right? Because that way, at least the fact that I'm working on that branch gets committed to the repo and my team would know about it. I was going to say, if you have a long-lived branch, rebase as often as you can. But the truth is you shouldn't have long-lived branches. We'll talk about this next. But if you're doing branch per feature, the feature should be small. If your branch is living for more than like a day or two, you're asking for trouble. So we'll come back to that in a moment. I think it's a fallacy to say, oh, this is a simple change, just do it on master. Programmers are optimists. We always think every change is a simple change, and we're usually wrong. We're like, oh, this is a one-line change. But then you change that one line, and you realize that that ripples, and it's going to affect another line somewhere in the file. And now you have to change a test because the test doesn't quite work the same way anymore. And pretty soon, you've left your paw prints all over various files on master. And that violates the invariant of master should always be safe to deploy from. So the solution to this is simple. Always do a feature branch. And by the way, a bug fix is a kind of feature. So a bug fix branch and a feature branch, kind of the same thing. Branching is basically free. And if you were really correct that it's a one-line change, you won't be. But if you were, you can delete the branch right after merging, and it's like nothing ever happened, right? You don't even push that branch to the origin repo, and the world doesn't even know the branch existed, but you maintain the invariant that master is always uncontaminated and clean right up until the moment that your pull request with your nicely rebased, everything is passing branch makes it into the repo. Organize your work. We really recommend that you work from a single repo, not from every developer having their own fork, for the reasons I said before. When you run into problems, I think you know some of my favorite strategies. Let me Google that for you is probably the strategy that I use most. Writing an effective Stack Overflow post, or a Piazza post for that matter. We had these guidelines at the beginning of the semester of really read the error message carefully. It's still surprising how many posts you see where it says, I have no idea what's wrong. And the error message says something like, file X in directory Y is missing and should be there. Or expected file X to define class Y, but it did not. If you read it and just sort of take it literally, you can get really, really far. And when you're composing that post, sometimes the act of composing the post will actually reveal the answer to you. You're like, oh, right, of course, that's what happened. So don't underestimate. High-functioning, streamlined development environment. What do I mean by that? It means that when you sit down to code, there's a ritual that involves typing at most 1 or 2 lines, and then you're ready to go. So in my case, I open my terminal window, I change it to the right directory, I make sure that my database is running, because for complex reasons I have to develop against Postgres, and I switch RVM to use the correct version of Ruby, because I have several different projects that use different versions. That's it. Once I have done those two things in my terminal window, the environment is in a predictable state. If you have to do a lot of manual tweaking just to get started on coding, ask yourself what you could be automating. Is it something that is just specific to you? Is it something that your whole team could benefit from? But as much as you can, automate away things that are multiple steps, because you just are increasing the risk that you'll manually not get the steps right. And then something won't work the way it normally does, and you won't know why. Have one place where all of the information is recorded. I love Google Docs, but it's easy for your project to become sort of this semi-connected graph of Google Docs all over the place. If there are documents that are associated with particular stories, Tracker has a way to do file attachments. It also integrates with Google Drive, so even having the links to Google Docs in your Tracker is an improvement. But at the end of the day, it'd be great if there's one place you can go to that starts your search for project documentation, or maybe the repo plus one other place. You may have noticed that some projects, as part of their GitHub repo, have a wiki. A wiki is actually a great place to capture information of interest to other developers. So for the students who are going to pick up your project next semester or the following semester, the wiki is a great place to document things like, in order to get this to run, you have to first deploy Redis, or you have to deploy Mongo, and here's how you do it. Or this file, this project assumes that the following environment variables are set correctly, otherwise it won't work. Right? So things that a developer would want to know, that stuff can go in the repo. Things having to do with designs, mock-ups, things like that, if you can attach them in some way to Tracker, you can, and that's kind of the project home. Technical debt. Technical debt is things that you kind of know are wrong with your project, and you have let them slide, and at some point you're kicking the can down the road and someone's going to have to deal with it. Things that are going to make your project difficult to maintain, especially for other people. What can you do to avoid accumulating technical debt? And by the way, it doesn't mean that your project doesn't work. You can have a piece of software that is functioning perfectly from the customer's point of view, but if it has a high technical debt, it means it's much harder for other people to pick it up and improve on it later. And as we know, part of the goal here is not just creating code that works, but code that is easy to maintain for others. So I've already mentioned this, but master should never be read. Having at least one invariant is really good, and having master be clean is as good as any. In terms of team practices, a few that you might adopt are, if a pull request lowers your code climate score by some threshold, it should be rejected. Right? A code climate score is a reasonable indicator of code maintainability. So if merging a certain set of changes would actually cause your code climate GPA to go down by a couple of points, that's kind of a big deal, right? At some point, even if all the tests are functioning, it's going to be somebody's problem to learn how to deal with that code. So do pay attention to what code climate tells you, and it's realistic to reject or at least ask someone to revise their pull request if it doesn't pass muster with code climate. If branches get too long, they become impossible to merge. So a branch shouldn't really have a reason to live for more than a day or two. Again, if you're trying to do break up the work into small pieces, there is no shame in doing a lot of one-point stories. And if that means that you have a small branch and the branch has a lifetime of a day, that is great. That is where you want to be, because each individual piece of work can then be pulled out or pushed back in as needed. So no piece of work is too small to be thought of as a feature that deserves its own branch. Any merge or PR that actually breaks the regression is reversed, meaning the merge is undone. You shouldn't really get to this point, because before you do a PR pull request to have your code merged, you should already have verified that it passes all the tests. But you can imagine this happening if the tests have been improved on master since you did your changes, and now there are some new tests that didn't used to exist, and those tests find new bugs in your code. Right? So again, this is part of never push red on master. And this is just me, but I believe in testing. If you're adding new code, you have to be adding tests that cover that new code. If you're fixing a bug, part of fixing a bug is a test that demonstrates that the bug was present in the absence of your fix and absent when your fix is applied. So if new code is submitted without the corresponding tests, that's a reason to reject it and say, go ahead and reopen your pull request after you have provided some tests that cover your new code. Because at the end of the day, everybody in the team is going to have to live with it. So concluding remarks about all this stuff. Small teams are good. They're not sort of, they're not magic. Banquet teams, if you want to think about a big organization with 30 or 40 people, a lot of the management problems associated with teams become much easier when you have a smaller team. In particular, staying in touch with what your team is doing through very lightweight daily stand-ups that could take as little as 5 minutes to do. Being able to use these informal mechanisms like points and velocity to have small chunks of work that are sort of easy to check off and that map nicely onto branch per feature. In a plan and document top-down environment, the project manager is sort of on the hook to do all of this stuff. I think it's both a pro and a con that in a team setting, you share responsibility for this. So if everybody sort of pulls their weight and you are checking in pretty frequently with each other, you can actually avoid a lot of the problems that larger teams have. And each iteration, think about what you've learned during the previous iteration. We actually are going to be providing a tool for you to do retros, iteration retrospectives. Things that went well or went badly could be technical things. It could be the way that you ran your scrums. It could be something about pairing. But basically, it's what would we do differently next iteration? Because if you're always improving, if you're learning from your mistakes, that's kind of the reason to make them. As you go off to your spring break, I will leave you with this thought. This is a post that I found. I can't remember if it was on Facebook or Reddit or where it was. When I die, I would like the people I did group projects with to lower me into my grave so they can let me down one last time. Oh, no, wait. But there was a comment. There was a comment on it that I thought made it even better. Your coffin will probably end up sideways because one person didn't hold up their side. Okay? Don't be that person.